Hey everyone, my name is Sahil, and in today's video, we will discuss the plate earthing diagram. You will learn how to read this diagram and understand each component. But why should you listen to me? At Axis, we've been manufacturing a wide range of earthing and lightning protection systems, including earth rods and earth plates for the past 30 years. You'll see our products installed in solar farms, data centers, commercial and residential projects around the world in more than 100 countries. So, let's start with the basics. What is earthing? In any electrical system, things can go wrong, wires can get damaged, insulation can crack, water can enter a switchboard, and many other things like that. But when this happens, electricity starts flowing where it should not. This unwanted flow is called a fault current. Fault current is dangerous because it collects on metal parts like panels, appliances, poles, cable armor, etc. And anyone touching these parts will get an electric shock. Earthing solves this problem by giving the fault current a low resistance path into the soil so that it returns to the source to protect human life and equipment. There are different types of earthing systems like plate earthing, rod earthing, strip earthing, and pipe earthing. The shapes are different, but the job is the same. Each one takes fault current safely into the soil. To do this, every system needs a metal piece buried in the ground, and this buried metal piece is called an earth electrode. It is that part of your earthing system that actually touches the soil and carries the fault current away from your equipment. In plate earthing, this electrode is a metal plate. So let me explain how plate earthing works. In plate earthing, you place a metal plate in the ground at a fixed depth. The plate is usually buried about 3 meters below the surface, so it stays in contact with moist soil. This plate connects to your equipment through a copper or GI strip, and the soil around the plate must stay moist because moisture keeps the resistance low. The lower the resistance, the faster the fault current moves into the soil. Now let's understand the diagram. First of all, starting with the plate. A copper plate is the main electrode used in plate earthing. This is the part that goes into the soil and provides the contact area for fault current to enter the ground. When a fault happens, the current travels down the earth strip and enters the soil through this plate. The large surface area helps the current spread quickly and lowers the overall earthing resistance. In plate earthing systems, copper plates are commonly available in sizes such as 600 by 600 mm with thicknesses like 3.15 mm or 6 mm. This plate is also available in galvanized iron, having a size of 600 by 600 mm with thickness of 6 mm. However, you can customize it depending on your project requirements. Secondly, the copper strip. This strip forms the electrical path between your copper strip terminal and the copper plate buried in the soil. It runs vertically from the plate up to the terminal at the top. When a fault happens, the current travels through the strip before it enters the ground. Its ability to carry fault current depends on its cross-sectional area, and the cross-sectional area is simply the size of the strip when you look at it at its cut face. And you get it by multiplying the width by the thickness. For example, if a strip is 25 mm wide and 3 mm thick, then 25 multiplied by 3 gives you 75 square millimeters. A strip with the highest cross-sectional area can carry more fault current safely. Now thirdly, the copper strip terminal. This terminal is the flat bar mounted at the top of the pit where the copper strip ends. It gives you a clear and stable point to connect the strip to the earthing system above the ground. The terminal has multiple holes so that you can bolt the strip securely and make future inspection or maintenance easy. Its job is simple: to hold the strip in place, provide a firm mechanical support, and ensure a clean electrical connection between the buried earthing system and the equipment on the surface. If you're finding this video helpful, please subscribe to our channel for more insightful videos on electrical engineering and earthing and lighting systems in general. Now fourthly, the GI pipe. This GI pipe is a perforated pipe for watering as shown in the diagram. Its job is to carry water down to the soil around the copper plate so the moisture level stays stable. Moist soil keeps the resistance low and helps the fault current move into the ground quickly, and the holes along the pipe allow the water to spread around the plate. This pipe is made of galvanized iron so it can stay in the soil for long periods of time without corroding. Fifthly, the funnel. This funnel with mesh is placed at the top of the watering pipe. You pour the water through this funnel to keep the soil around the plate moist. The mesh prevents stones, leaves, or debris from entering the pipe and blocking the flow of water. Using a funnel and mesh keeps the watering arrangement clean and accessible so that moisture can reach the electrode effectively. Now, the U-bolt. These bolts hold the plate earthing assembly in position and keep the copper strip aligned as it rises towards the terminal. Their job is mechanical, not electrical. They make sure the strip does not bend, twist, or shift inside the pit. A stable strip helps maintain a reliable path of the fault current. I hope you now have a clear idea about the plate earthing diagram. At Axis, we have a team of 50+ engineers who design, install, and test earthing and lightning protection systems as per your requirement. Our products have been used in substations, data centers, factories, and even in everyday residential and commercial buildings. If you liked this video, please like the video and subscribe to our channel for more insightful videos on electrical engineering.